5 steps turn ordinary sand into a $30,000 AI chip wafer. It takes a $1 billion machine and more than 3 months. Here's every step. Every AI GPU on Earth depends on this one process. No wafer, no ChatGPT, no AI boom. And here's the part almost nobody clocks. The whole world's most advanced chips flow through one company's machines. That makes this the tightest choke point in tech. Step 1. Start with sand. Silicon is pulled from ordinary sand, purified, and grown into a single perfect crystal. Then it is sliced into thin round wafers, polished mirror smooth. Think of that wafer as a blank canvas. Nothing is printed yet. And getting from this blank disk to one full of working chips is not quick. According to industry breakdowns, it takes thousands of separate steps. It takes more than 3 months from design to finished production. 3 months for one disk. So before a single transistor exists, you already need a spotless factory and months of patience. But how do you print circuits far too small to see? Step 2. The light. To print circuits, you shine light through a stencil onto the wafer. It works like a projector casting a shadow. The catch is simple. You can't draw lines finer than the light you're using is wide. Older machines used a kind of light called DUV, deep ultraviolet. To go smaller, the newest machines switch to extreme ultraviolet, or EUV. Here's the number that matters. EUV light has a wavelength of just 13.5 nanometers. That's more than 14 times shorter than the DUV light in older tools. 14 times finer means 14 times sharper lines on the chip. Shorter light, smaller transistors. But making light that short is where things get genuinely absurd. Step 3. How you actually make that light. This part sounds made up. Inside the machine, molten tin droplets about 25 microns across, thinner than a hair, are fired out at 70 meters per second. Each droplet gets hit twice. One laser pulse flattens it into a pancake. A second, stronger pulse vaporizes that pancake into a superheated plasma. The plasma spits out the 13.5 nanometer light. Now the pace. The lasers strike droplets 50,000 times every single second. 50,000 tiny explosions a second, just to make the light that draws the lines. Zoom out and you realize this only exists inside one specific machine. So who builds it? Step 4. The machine and the monopoly around it. Only one company on Earth builds these EUV machines for high-volume production. That is ASML in the Netherlands. By its own market's count, ASML holds roughly 94% of the entire chip lithography equipment market. One firm, almost the whole world. And the newest generation, called high-NA EUV, ships to factories at about $400 million each. That's not a typo. One machine, the price of a skyscraper. In return, it resolves features as small as 8 nanometers, roughly the width of 40 silicon atoms lined up. So a single supplier, a single machine, and detail measured in atoms. That's the choke point. Which finally explains the price. Step 5. Print, repeat, and total it up. The machine prints one pattern layer. The wafer shifts and it prints again layer after layer, until a full grid of chips takes shape across the disk. Do that across those thousands of steps and here's the bill. TSMC set the price of its most advanced 2-nanometer wafers at around $30,000 each. $30,000 for one polished disk of former sand. And that price climbed for a reason. It's a 10 to 20% jump over the roughly $25,000 to $27,000 that its previous 3-nanometer wafers averaged. Finer light and harder printing cost more. That's why the number is so high. Now the whole chain clicks. Sand becomes a wafer. To print it, you need 13.5 nanometer EUV light. To make that light, you fire tin droplets 50,000 times a second. And that happens inside a $400 million machine only one company builds. Repeat thousands of steps and you get a $30,000 wafer. That's why one GPU takes more than 3 months and a machine that costs as much as a skyscraper. And it's why this chain is so fragile. Thousands of steps plus one single supplier at the center is exactly why the world's AI chips are scarce and expensive. One weak link and everything downstream waits. The takeaway: the entire AI economy balances on machines from essentially one company in one country. That's not a stock tip, just how the supply chain sits today. This is information, not financial advice, so do your own research. I break down one of these every day. Subscribe and the next chip chain story finds you.